Okay, hello everyone in a new video. So we have reached part 2 of chapter 5, which is the chapter of electric power and energy in the second unit of electricity. Then we have reached section 7, which is the electric energy. Then let me write down the title of this section, which is given by the electric energy. Previously, we have defined electric power, and whenever we define power, we can directly define energy. Then let me say electric energy is a form of energy So recall that energy by itself have different forms. We have mechanical energy, kinetic energy, potential energy, energy in the form of heat. Electric energy is one of these forms, and this results, so it is a form of energy resulting from the flow of electric current. So given an electric component D being traversed by a current I having an applied voltage U, so it consumes power P, and this power is electric power. We can directly define the quantity E, which is the electric energy, in the form of electric power. Okay, and let me write the formula of the energy that is related to the power. Let me say the electric energy of an electric component is given by E so E is equal to P multiplied by T. So, and we know that any formula in physics consists of three variables. We can directly construct its triangle. So here, because we have multiplied, then E will be at the top, P and T at the bottom. Suppose we are interested in determining the value of P, then P is given by E divided by T, and the value of T is simply given by E divided by P. Now let me define what does each of these quantities represent, and let me say where E, which is the first letter of energy, is the electric energy, and its SI unit is given by capital J, which stands for joules. Now as for P, we have seen previously what is meant by P. P is the electric power. And the unit of the electric power is given by watts, capital W, which stands for watts. And as for T, T is said to be the time, and SI unit is S, which stands for seconds. Now notice that in this case, E and P are variables living at different floors, so they behave in the same manner or love each other. So whenever E increases, P increases. So we say that E and P are directly proportional. to the power. And notice that also E and T are variables living in different floors, so they love each other. Whenever T increases, also E increases, which means that E and T are also directly proportional, and the electric energy is also directly proportional to time, so to power and time. Now, for example, suppose that we have an electric component. Its power is given by P is equal to 5 watts and T is equal to 2 seconds. We are interested in calculating the energy. Simply E is given by P times T. So the value of P is given by 5 in the SI and the value of T is given by 2 in the SI. So this is given by 10. Since P and T are expressed in the SI, so the value of E will be in the SI, which is joules. Then E is equal to 10 joules. But notice that in our case, so let me say that also, or let me say the following: joules which is simple is given by J is the SI unit of energy. Now, okay, another convenient unit of electric energy is kilowatts hour. So usually we see this unit when the consumed energy is over a long period of time, like days, other than days we have, say for example, weeks, and months. So here what I wanted to say is that the SI unit of energy is given by joules, but we have other convenient units of energy. For example, if you are measuring like the mass of a car, it's more convenient to use tons instead of kilograms. So now in the following sections and exercises, we are interested in determining the electric energy consumed by certain electric component or appliances. Then we are interested in a typical unit of energy, which is given by kilowatts hour. So let me explain why kilowatt hours is a unit of energy. We have previously said that E is equal to P times T. Now notice that kilowatt hour can be written as kilowatt multiplied by hour, which means that P in this case must be expressed in kilowatts and time must be expressed in hours. So for this reason, kilowatt hours is a unit of energy, as we shall see in the next section, which is the section of the electric bill. And let me directly move to section number 8 and explain what is meant by kilowatt hour. And the title of this section is given by calculating the electric bill. So suppose in this case we have an electric appliance, for example, say a washing machine, and we are interested in calculating the electric bill the price that we pay for the functioning of the washing machine, for example, say for 1 day, 1 week, or even 1 month. And let me start by the first idea, which is the daily consumption. In kilowatts hour. So notice that here K and W are capital, in which H is a lowercase. So what is meant by daily consumption in kilowatt hour? Suppose, okay, so, or let me say the following. Step number 1 is to find the power P consumed by the electric component in kilowatts, which is given by kW. So we have this washing machine. We will first, so as a step number 1, convert its power from watts into kilowatts. Okay, now step number 2, and this is done by dividing simply by 1000, as we shall see in the coming exercises. Now step number 2 is to find the electric energy which is given by E1. E1 represents the electric energy consumed by the washing machine, say for example, which is consuming a power P, consumed for several hours. So here 1 stands for 1 day, where the time is given in hours. So after we have converted P to the kilowatts, now we need to calculate the electric energy consumed by this electric appliance for 1 day. So we know that E and P are related by that E is equal to P times T, and here E carry the label 1 because we are calculating the electric energy consumed per 1 day. So it's given by the power multiplied by the number of hours in a day. And by using this formula, now we have determined the daily consumption in kilowatt hour. Why? Because if T is expressed in hour and this is in kilowatts, so the unit of E1 will be simply kilowatt multiplied by hour. Now idea number 2, which is the monthly consumption. So E1 represent the electric energy consumed per 1 day functioning for a certain amount of hours. Now if you are interested in determining the monthly consumption, so we simply multiply by the number of days in which we are using this electric appliance. So let me say monthly consumption. So let me say that this is step number 3. Find the electric energy E consumed for 1 month. So in this case, simply E is given by E1 multiplied by the number of days per month Now here I didn't specify what is the number of days per month, and this depend on the exercise itself and depend on the number of days that we are using this electric appliance. We can use it for 15 days, 28 days, 30 days, 5 days. Okay, so this depends on the exercise itself. Now after we have determined E, which represents the electric energy consumed per month, now we can determine the monthly cost. So step number 4, simply the monthly cost is given by E times the price. And here let me summarize. So the price also is given in the exercise. Now here let me summarize the different steps that we will follow in order to calculate the electric bill. So step number 1 is to find the power in kilowatts. So find the power P consumed by the electric component in kilowatts. Then step number 1 is to convert P into kilowatts. Now step number 2 is to find the electric energy consumed E1 for several hours in a day. So we will determine E1 for 1 day. Step 3 is to find the electric energy E consumed for 1 month. So we will find E for 1 month. And step number 4, we will find the cost. And the cost is simply given by E times the price. Now we will follow these different steps in any exercise concerned and related to calculating the electric bill as exercise number 5 and section number 9. So they are telling me the water heater is used at the rate of 6 hours per day and the consumed power is 1130 watts. Now the moment they mentioned hours and the power, which means that we are interested in calculating the electric bill, so let me write here the answer of exercise number 5 and let me start by writing the given properly. We have that T is equal to 6 hours. Knowing that hours is not the assigned unit of time, in order to convert from hours, in this case, no need to convert hours into seconds because we are interested in determining the electric bill. So it's more convenient to leave T in hours because notice that later on we need to determine the unit, the energy in kilowatt hours, so time must be kept in hour. Now let me write here on the scratch that step number 1 is to convert P to kilowatt. Now step number 2 is to calculate E1 for 1 day. Step number 3 is to determine E for 1 month. And step number 4 is to determine the cost, which is the energy multiplied by the price. These are not part of the answer, these are on the scratch, okay? Now, and they are telling me that the electric power P is given by 1130 watts. Now let's proceed. In number 1, they are telling me determine in kilowatt hour, not okay, the electric power consumed by the water heater. So they are asking me about step number 1. We are done with step number 1. So in order to convert watts into kilowatts, recall that in order to convert from, say for example, kilovolts into volts, we multiply by 1000, which means that from volts to kilovolts, we need to divide by 1000. Similarly here, in order to convert from watt to kilowatt, we divide by 1000, okay? So P, which is equal to 1130 watts, so which is equal to 1130 divided by 1000, which is equal to 1.13 kilowatts. So simply the power P is given by 1.13 kilowatts. So as you can notice that they don't directly ask me about step number 4. So these parts are in order for us, so they allows us to proceed in the following steps, okay? Now number 2, they are telling me calculate in kilowatt hour the electric energy consumed by the water heater in one day. We are interested in determining the electric energy. The formula of the electric energy is given by E is equal to P times T. And they are telling me for 1 day, so the energy will carry the label 1. And notice that here they are specifying the unit, which is given by kilowatts and kilowatts hour. Kilowatts hour can be decomposed into kilowatt multiplied by hour, which means that the power must be expressed in kilowatts and time must be expressed in hours. For this reason, I have left T to be in hours, knowing that the SI unit of time is seconds. Now, so this is equal to power. The power that we must use is given by kilowatts. So 1.13 multiplied by 6. And plugging this on the calculator, then the value of the electric energy E1 consumed per 1 day is given by 6.78 kilowatts hour. Why kilowatts hour? Because P is expressed in kilowatts and T is in hours. So the electric energy E1 is given by 6.78 kilowatts hour. And we are done with the step number 2, because recall step number 2 is to calculate E1 for 1 day. Now in part 3, they are telling me determine the monthly cost to be paid. So they are directly asking me about step number 4. By the consumer using this water heater, knowing that the average price of 1 kilowatt hour is 100 Lebanese liras, take 1 month is equal to 30 days. So they are asking me about the costs. Before we calculate the costs, we need to do step number 3. Step number 3 is to determine the energy for 1 month. So the energy for 1 month is given by E is equal to E1 times the number of days. Or let me say directly, okay, number of days, which is equal, now E1 is given by 6.78 multiplied by the number of days we have. So the number of days in 1 month, notice that here they are telling me take 1 month is equal to 30 days. Now plugging this in the calculator, then the answer is given by 203.4. Since this is expressed in kilowatts hour, then this value is expressed in kilowatts hour. So now E, this energy, represents the consumed energy not for 1 day but for 1 month, because simply we have multiplied E1 by the number of days. So now after we have determined the electric energy consumed per 1 month, now we are done with the step number 4, and we are ready to determine the cost. So I'm still in part 3. So the monthly cost is simply given by 200. So let me say, okay, 203.4 multiplied by the price, and the price is given by 100 Lebanese liras multiplied by 100, which is equal 20,304. Because this is expressed in Lebanese liras, then the value will be expressed in Lebanese liras. So the monthly cost is given by 20,304 Lebanese liras. Okay, so this is it for exercise number 5. Now in exercise number 6, they are telling me the heating plate is used for 4 hours per day, so T is equal to 4 hours. And the consumed power is given by P is equal to 880 watts. So if you look at the exercise overall, it seems that they are asking me about the electric bill. So let me here write on the scratch the different steps that we follow in order to determine the electric bill. Then step number 1 is to convert P into kilowatts. Step number 2 is to determine the energy E1 for 1 day. Step number 3 is to determine E for 1 month. Then step number 4 is to determine the cost. Now in number 1 they are telling me calculate the energy in kilowatt hour consumed by the plate during 1 month, which is 30 days. So they are asking me about the energy consumed by the plate during 1 month. Then they are asking me directly about step number 3. So we need to do step number 1 and step number 2 before proceeding to step number 3. So P is equal to 880 watts. We need to convert this to kilowatts. So 880 divided by 1000. So this is equal to 0.88 kilowatts. And this is reasonable. Why? Because notice that kilowatt hour, this unit can be decomposed into kilowatts multiplied by hour, which means that the power must be in kilowatts and the time must be an hour. So now we just converted the unit of P. Now we need to determine, we are done with the step number 1. We need to determine the electric energy consumed per 1 day, which is given by E is equal to P multiplied by T. Don't forget, we always start by writing the proper formula. No need to construct a triangle. The value of P is given by 0.88 and the value of T is given by 4. Plugging this on the calculator, then its value is given by 3.52. Since P is expressed in kilowatts, T is expressed in hours, so the value of E1 is given by kilowatts hour. So this is E1 for 1 day. However, we are interested in determining the electric energy in kilowatt hour consumed per 1 month, which consists of 30 days and not for 1 day. So simply E, which is equal to E1 times the number of days, which is equal to 3.52 multiplied by 30. Plugging this value on the calculator, then the electric energy consumed per 1 month in kilowatt hour is given by 105.6 kilowatts hour. Then E is equal to 105.6 kilowatts hour. And by this, notice that this one corresponds to step number 2. Then we are done with the step number 2, and this one corresponds for step number 3. Now in number 2 they are telling me the corresponding monthly okay, we need to calculate the corresponding monthly cost, knowing that the average price of 1 kilo of the kilowatt hour is 100 Lebanese liras. We know that the electric energy overall is given by 105.6. So in order to determine the price, the cost we simply multiply by the price. So the cost is simply E times the price, which is equal to 105.6 multiplied by 100, which is equal to 10,560 Lebanese liras. So the cost, this is the cost in this case. And we are done with the step number 4. Let me refer back to the previous exercise, and here let me write that this is given by, so this is wrong. I have noticed that I have done something wrong here. For this reason I have referred back. Let me say here that, so this is multiplied by 100 and it's given by 340 Lebanese liras. So this is given by 20,000 1340 Lebanese liras. Okay, so the formula here is given by E times the price, which is equal to, okay. Now in exercise number 7, they are telling me the power of the water heater P is equal to 968 watts. So if we take a look at this exercise overall, and then we notice that we are interested in determining the electric bill, and let me write here on the scratch the different steps that we follow in order to determine the electric bill. Then step number 1 is to convert P into kilowatts. Step number 2 is to determine the electric energy for 1 day. Step number 3 is to determine E for 1 month. Step number 4 is to determine the monthly cost. Now P is equal to 968 watts. Now in number 1, they are telling me calculate in kilowatt hour the electric energy consumed by the water heater here we have water heater during 5 hours of functioning. Then we are interested in determining the electric energy. Since we are talking about 5 hours, so these 5 hours are less than the duration of a day. So simply they are asking me about E1 for 1 day. So in order to determine step number 2, we need to proceed with the step number 1. Now P, which is equal to 968, then dividing, in order to convert this into kilowatts, simply we divide it by 1000, so this is equal to 0.968 kilowatts. So the power is given by 0.968 kilowatts. Now after we have done with step number 1, let's move to step number 2, which is what is required from us is calculating the electric energy, and the formula of the electric energy is given by E is equal to P times T. Since this duration corresponds for 1 day, let me write here the label 1. And notice that kilowatt hour is the unit of energy, and this can be decomposed into kilowatt multiplied by hour, which means that power must be expressed in kilowatts and time in hours. Okay. So the value of P, which is given by 0968 in kilowatts, and the time T in hours, which is given by 5. So plugging this on the calculator, then the value of E1 is given by 4.84 in kilowatt hours. So why kilowatts hour? Why kilowatts hour? Because simply P is expressed in kilowatts and T is in hour. So 4.84 kilowatts hour. Okay. Now we are done with the steps 1 and 2. Now they are telling me the water heater function for 15 days. So the number of days is given by 15 in 1 month at an average rate of 5 hours daily. Okay. So each day is considered to be 5 hours and each month is considered to be 5 days. Now in 2.1, calculate the electric energy consumed by the water heater during 1 month. They are asking me about step number 3. Then E is simply given by E1 times the number of days, which is equal to 4.84 multiplied by the number of days in 1 month, which is given by 15. Now plugging this on the calculator, then the value of E, the total energy consumed per 1 month, is given by 72.6 kilowatt hour. Then E is given by 72.6 kilowatt hour. And for 2.2, they are telling me deduce, and by deduce it means that we notice the previous part, the monthly amount to be paid. We are being asked about the monthly cost. So the monthly cost is simply given by cost, so or E times the price. They are telling me the average cost is given by 100 Lebanese liras, so E, which is given by 72.6, the total energy multiplied by 100, so this is given by 7,260 Lebanese liras. Okay, then this is the cost. Okay, so this is it for the electric bill. And now let me move to the other section, which is Joule's effect. Or still we have exercise number 8, sorry. Okay, no. Before exercise number 8, I need to explain Joule's effect. So we have done 3 exercises, okay. Now, so section number 18, which is given by Joule's effect. Let me say idea number 1. The flow of an electric current in any conductor is always accompanied by the liberation of heat. The transformation of electric energy into thermal energy is called the Joule's effect. So always the transformation of any type of energy into thermal energy, this is called the Joule's effect. No, the transformation only of electric energy. So whenever we are going from electric energy into thermal energy, only electric energy into thermal energy, this is given by Joule's effect. And now let me write, so what is Joule effect? Is the transformation of electric energy into thermal energy. And now let me write idea number 2 and say when we make use of the transformation into thermal energy, this is an advantage of Joule's effect. Otherwise it is an inconvenience. So what do I mean by this? Let's consider 2 types of electric components or electric appliances. Suppose that here we have a lamp and here we have a heater. So the lamp gives 2 types of energy, but the main energy is given in the form of light. And also if we put our hand close to the lamp, we can feel the heat which is liberated from the lamp. But the heater, the main reason behind the heater is to give only one type of energy, which is given by the heat. Okay. So now this type of heat which is liberated from the lamp is considered as inconvenience. Why? Simply because we can't make use of this type of energy which is heat. Okay. But this is considered as an advantage simply because we make use of this type of energy which is the heat. Okay, so whenever we make use of we make use of the thermal energy, which is the heat. This is said to be an advantage of Joule effect, otherwise it's said to be an inconvenience. Okay, so I repeat, whenever we make use of the thermal energy, this is said to be an advantage of Joule effect. And now let me write idea number 3. Electric appliances that are considered as an advantage of a Joule's effect are basically made of resistors, because we know that a resistor is an electric component that transforms electric energy into thermal energy, because resistors are electric components that transform so why the heater gives heat? Because simply it's made up of resistor. Okay, and now let me move to the next section, which is an exercise directly on Joule's effect. So in exercise number 8, they are telling me arrange the following electric appliances into an advantage or an inconvenience of Joule's effect. So this is straightforward. Here we have 1, 2, 3, 4, 5, 6 appliances. We just need to classify these appliances as advantage or inconvenience. So let me write here advantage, and let me write here inconvenience. Now all of these appliances, they give heat, but the one that we make use of this heat are classified as an advantage. So we have the iron, so also we have the electric heat radiator, and the immersion heater. Or other electric components, they liberate heat, but we cannot make use of this heat. So the Wi-Fi router, the LED screen, and the electric lamp are classified as, so the Joule's effect is classified as inconvenience. Okay, and now let me move to the next section, which is given by indications on electric components. We have seen indications, so we have seen previously indications. On electric components. Like 12 volts, 0.5 amperes. Now we will go over an additional one. So let's consider the following example. Given a lamp L with the following indications. So let me write the indications here. And we are interested in the following question. What does these or the above indications mean? Now we have seen previously what is meant by 12 volts and 1 ampere. They are related voltage, rated current under which the lamp L functions normally. Now it's left to explain what is meant by 12 volts. So this is simply the rated power consumed by the lamp L under normal functioning. Now as for 12 volts, we know that it's given by the rated voltage of the lamp L under which it functions normally. And 1 amperes, what does it represent? It carries the unit amperes, which means the rated current. So recall also the 12 volt is the rated power because it carries the unit of power, which is watts. So rated current functions normally. Here let me write is the So 12 volt is the rated power and 12 volts is the rated voltage of the lamp L, and 1 ampere is the rated current of the lamp L under which it functions normally. Okay, and finally the last thing that I want to discuss. So now we are in which section? We are in section number 15. Let me write now. So different methods to determine the voltage. So starting from the early methods, we have seen the law of uniqueness of voltages. We have seen a very important law. So here let me write from or using. Now the second method is from law of addition of voltages. Now the third one, which is given by from reading of a multimeter, which is in this case being used as a voltmeter. or an oscilloscope. Now idea number 4, which is given by identical, or fourth method, identical electric components in series. The fifth one is given by from the indications. Or referring even to the graph. U versus I, because recall that if we know the curve, by referring to I and to the curve we can determine the value of U. Now idea number 7 from the famous law, Ohm's law. And idea number 8 is given by from the electric power. P is equal to U times I. Now mainly, whenever we are performing calculations, not to justification, we will refer to this method, and to this one, and to this one. All other methods are to justify or to explain why the ones that are marked in blue are used for calculation, okay? And now let me write something similar for methods to determine the current, the electric current. So the first method, which is in analogy with what I have written above, is given by from a law of uniqueness of currents, or in agreement. Now the second one is given by from law of addition of currents. Now idea number 3 is given by from. So notice that here I will not write the oscilloscope, I will only write the multimeter functioning as an ammeter. From reading of a multimeter Now idea number 4, instead of writing identical components in series, we'll write in parallel. Now idea number 5, also from the indications, we can determine the current. Now also here, if we know U and we refer to the curve, we can determine I. So let me write referring to the graph U versus I. As for idea number 7, also from the famous law, Ohm's law. And finally, the new method that we have added in this chapter for both voltages and currents is given by from the electric power. P is equal to U times I. So we have 8 different ways, at least, in order to justify the value of the electric current, but the one that you are interested in the case of calculation, is given by 2. also from Ohm's law, and from P is equal to U times I. Okay, so that's it for me in this video, guys. In the next part we will solve exercises on this chapter.